everyone. Today, I will be presenting how we applied a linear regression model on the diabetes dataset using Python. The goal of this project was to predict the progression of diabetes based on certain medical features of patients. Importing libraries. The first step was importing the required libraries. We used NumPy and Pandas for data handling, Matplotlib for visualization, and scikit-learn for machine learning tools like linear regression and evaluation metrics. Loading the dataset. We then loaded the diabetes dataset from scikit-learn. This dataset contains medical features such as BMI, blood pressure, age, and others. Our target variable is a numerical value that represents the progression of diabetes. We converted the data into a Pandas data frame for better visualization and understanding. Splitting the data. To evaluate our model properly, we split the dataset into two parts. 80% for training the model and 20% for testing it. This ensures that our model is trained on one portion of the data but tested on unseen data to check its accuracy. Training the linear regression model. We then created a linear regression model and trained it using the training data. What the model does here is try to find the best fit line that explains the relationship between the input features and the output target variable. Making predictions. After training, we used the model to make predictions on the test dataset. This gave us predicted diabetes progression values for the patients in the test set. Model evaluation. To check how well our model performed, we calculated two metrics. First, the mean squared error, which tells us how far our predictions are from the actual values. And second, the R² score, which measures how well the model explains the variation in the data. An R² value closer to 1 means a better fit. Visualization. Finally, we plotted a graph of actual versus predicted values. Each blue dot represents a patient's predicted and actual diabetes progression. The red dashed line represents the ideal case where predicted equals actual. The closer the points are to this line, the better our model is performing. Conclusion. In conclusion, we successfully applied a linear regression model to the diabetes dataset. The model was able to learn the relationship between patient features and disease progression. We evaluated its performance using error metrics and visualized the results with a scatter plot. This demonstrates how linear regression can be effectively used for supervised machine learning tasks to predict numerical outcomes.